Graph Theory Class 13 Video 3. In this video we're going to talk about the travelling salesman problem, and in particular a heuristic argument for finding a solution to the travelling salesman problem. So before I go on to tell you exactly what the algorithm is and how it works, I want to say that this is only a heuristic algorithm. And by that I mean that this algorithm, it gives you a solution, but it might not be the best solution. So remember, the travelling salesman problem asks you to find the shortest Hamiltonian circuit. Well, this algorithm, it will give you a Hamiltonian circuit, and a lot of the time it's pretty short, but it's not guaranteed to be the shortest one. Okay, it's not guaranteed to always give you the shortest Hamiltonian circuit. That's just such a hard problem that there is no nice algorithm which can give you the answer. So instead you have these other algorithms which are like a compromise. They give you a pretty good answer most of the time. Okay, and that's what we're going to look at in this video. So let's move on to the definition. It's called the nearest neighbor algorithm, and I just use NNA for short. And it's a very simple algorithm. It's 3 steps. So the first step is you choose a start vertex. Again, I will probably tell you where to start. If there's a question in your homework or the final exam or whatever, I'll probably tell you which vertex I want you to start at. Once you have a start vertex, you travel to the nearest vertex not already visited. Okay? So because we're dealing with complete graphs, you have the option of traveling to any other vertex. And I just want you to travel to the nearest vertex not already visited. Okay? So nearest means shortest distance away. And then step 3 is just you repeat step 2 until you've visited every vertex, and then you return to the start vertex. Okay? So it's a very simple algorithm. It's what's known as like a greedy algorithm, because it's not very clever. Like, you just do the most naive thing at every step. At every step of the algorithm, you just look around and you say, where's the closest town, the closest vertex I haven't already visited, and then you go there. So it's a really sort of greedy, naive algorithm, but it's pretty good. So let's do an example. Here is a graph, and it's got the weights on it, and the question is just apply the nearest neighbor algorithm to the following graph, starting from vertex A. Okay, so I'm starting from vertex A. Now I'll keep track of my path. So I know I start at A, I just need to find out who's my nearest neighbor. B is a distance of 2, C is a distance of 8, D is a distance of 4, and E is a distance of 6. So that means B is my nearest neighbor. So I go to B next. Okay, now I'm at B. And I look around and I say, who's my closest neighbor? Well, I can't go back to A because I haven't visited all the other vertices yet, so that would be illegal. I can't go back to A just yet. But I can go to the other vertices. So C is 5 away, D is 7, and E is 9. So that means C is the next nearest. So I go to C, like that. Okay. Now I'm at C, and I look around. There are only 2 vertices I haven't been to yet, and which one's closer? Well, D is 3 units away, and E is 10 units. So that means D is closer. Okay. Now, there's only one place I haven't been, so I have to go there. So I go to E. At this point, I've visited every single vertex. So I just return back home, like that. Okay? And the total weight of this particular Hamiltonian circuit is, well, it's going to be 2 plus 5 plus 3 plus 1 plus 6. So if you add that all up, it's 17. Okay? So this is how to answer this question right here. Okay, let's try this again, but let's maybe this time start at a different vertex. So again, apply nearest neighbor algorithm but this time I want to start at B, maybe. So this time I'll start at B. So let me erase the stuff I have here right now. And this time I'm starting at B. So I'll try and do it in a different color. Okay. So the first thing I write is B. Now, who's the nearest neighbor? Well, there's a 5, a 7, a 9, and a 2. So the 2 is the nearest. So I go B to A. Now I'm at A. Who's the nearest neighbor? There's an 8, a 4, and a 6. Well, the 4 seems like the smallest number, so that takes me down to D. Okay. At D, there's a 3 or a 1. 1 is the smallest, so that takes me up to E. At E, by this point I've been everywhere apart from C, so I have no choice. I have to go down to C next. Which is unfortunate because it's a 10, and a 10 is quite big. But I have no choice. I have to go to C. And now, at this point, I've been everywhere. I just need to return back home. So I return back to B. Like that. Okay. And the total weight of this particular Hamiltonian circuit is going to be 2 plus 4 plus 1. So it was 2 plus 4 plus 1, and then plus 10 and plus 5. So this is 6, 17, 22. Okay. And this highlights an important fact, right? I applied the same algorithm to the same graph 2 times, but I got different answers. I got 17 and I got 22. And the reason for this is I started at different spots. So this algorithm, it very much depends on where you start. You can get very different answers if you start in different locations. Okay? That's the end of this example. This is the nearest neighbor algorithm, and that's the end of this video.